Hello. Let's look at review exercise number 11. This is once again yet another normal probability problem. The mass of a bag of M&M candies is labeled as 47.9 grams. If bags go below the advertised mass, the company may lose customers because they're mad about not getting enough M&Ms in their bag, and they may have to pay fines from the government for false advertising on their false labeling on their packages. So they don't really want that to happen very often. Suppose that the actual mean masses are normally distributed with a mean of 48.1 grams. So they're going to have a mean a little bit above the target there. And a standard deviation, let's say, of 1.5 grams. So assuming these are accurate and that we have normally distributed, then give probabilities as percentages rounded to 1 decimal place. And let's see if we can figure this out. What proportion of bags will be below the advertised mass? What proportion of bags will have a mass more than 50 grams? What's the 90th percentile for all bag masses? And what interval of masses contain the middle 50% of all bags? Okay, see if you can work this out. Next slide is going to show you all the answers, so work all 4 of these answers before going on. Press pause now. All right, first thing I'm going to do with one of these is take the 48.1 stored as M and the 1.6 stored as S, and then I can just refer to the mean as M and standard deviation as S, and I don't have to worry about what number it is. Okay, so the normal CDF is going to give you a probability. We want the proportion or probability. The proportion of bags that are below the advertised mass is the probability of selecting a single bag that is below that. And that's a probability to the left of the mass of 47.9. So we want to go from, well, the lowest mass you could have is actually 0. So let's just go from 0 to 47.9 with that M and S, and we get 0.44696. You could have used M minus 10S instead of the 0. That would have given the same thing. So that happens about 44.7% of the time, which is, quite a bit in this case. So they might want to, if this was true, this may not be true data here, but if it was, they might want to change their thing a little bit here. What proportion will have more than 50 grams? Well, that's 50 on up. There is no real upper end here, so we're going to use M plus 10S in place of infinity. So 50 to M plus 10S with M and S, that's 10 standard deviations above the mean. There's very little probability above that. Not 0, but it's so small it doesn't affect the digits in the calculator will show. And so you work that out, you get 0.1026, etc. So that's about 10.3% that will be above that. What's the 90th percentile? So this is going to be an inverse normal probability. So the inverse norm is 0.9. Of 0.9 with M and S is 50.0 grams. So 90% of the time you'll get 50 grams or less. Okay. What interval of masses contain the middle 50%? Well, the middle 50% is going to be centered up on the mean, and it's going to go, 25% below and 25% above the mean. So that means that's going to go, well, those are your quartiles, right? The quartiles knock off the middle 50%. So we want to find those quartiles. So we want to do an inverse norm of 0.25 with M and S, and that'll be the probability that we find something below that is 25%. It'll find the X value, not the probability. And so that's 47.1 grams. And then we do an inverse norm of 0.75 with the M and S. There'll be a probability below that is 0.75. And so that X value is 49.1. That's the third quartile or 75th percentile. And so 50%, the middle 50% of the bags will have between 47.1 and 49.1. So they actually need to probably start packing a little more in this, so they're going to get a little bit trouble with 44%, almost 45% of the time being underweight. They're going to get caught on that. So probably in reality, if it really is labeled this is probably incorrect. They probably actually have a little higher mean, or maybe they have a smaller standard deviation if they're really good at it.